All right, when we're in the cafeteria, they're going to give you instructions like, hey, your formula sheet's on the back of your test, rip it off. You have scrap graph paper on the back of your test. If you want to rip that off, you can. And then the last direction is going to be, you need to clear your calculator's memory. All right. And the reasoning behind it is, some of you probably aren't aware of this because you would never think about doing this or ever do it, is that you can store stuff into your calculator. Formulas, theorems, facts. Okay. Heck, if you're taking that long to type all that in, you could be studying, right? So we need to clear all that out just in case. All right. So I want to go over today, probably tomorrow, Friday, how to clear your calculator, because I don't have the time to go desk by desk and remind you of the directions. Okay. So first step, everyone sees above the plus sign, you have MEM. That's short for memory. So you want to go second plus. Second plus. And everyone see number 7, reset. Second plus 7. Don't do anything yet. Here's where you got to focus in. There's a couple types of memories in your calculator. You want to scroll over to all. We're clearing all the memory, just not a certain part of it. All the memory over. So go over to all memory, enter, and then reset. So second plus 7, go over to all, reset everything. And then eventually, you may not have it on your screen right now. You're going to have something that says mem cleared. Eventually, maybe take a little bit, or maybe you have it on your screen right now. I'm going to go walk up and down our aisle, and all you're going to do is leave your calculator on your desk, and I'm going to see that mem cleared screen, and you're good to go. Okay, that's all I need. I don't want to see, it shouldn't say RAM cleared. Then I got to stop. I got to embarrass you in front of the whole cafeteria, and we got to wait for you to reset your memory again. So it should say mem cleared. All good? All right. Right after, and we'll probably remind you too, but right after I roll by and give you the okay, you need to hit your mode button. Hit your mode button. As soon as I give you the okay, you're good. And change it into degree mode. Okay? So you can get all the sine, cosine, tangent problems right. So change it into degree mode after. Right after I go by your desk, it's going to be quick. I'm like, thank you, boom, boom, up and down, because I got 50 plus kids in the cafeteria that day. All right, so change it to degree mode. All right? Any issues? We'll practice that again tomorrow, Friday, next week, so we're good to go. All right, good deal. Last night, I suggested some part 2s. Some of which were already done from previous days in here, but part 2s. Anything in particular you guys want to talk about here with me? Luke, hi. 31. 31? Yep. You know this is going to be on there. Perpendicular through a line and going through this point. It might not say perpendicular, it might say parallel for us. And it's going to shut down on me. Yep. Give me a sec here while we work out the technology. Well, I'm waiting for this to shut down and shut. No, all right. Textbooks. I got a lot of people in here that borrow textbooks for the year. Let's get those back in now. All right. You don't need them. All right. You don't need them. Please give them to me. All right. Please give them to me when you check them in. Don't put it on the pile over there. All right. Because I have to check it in on my spreadsheet. So please give it to me. I got a list of names. Maybe at the end of class, if we have time, we'll go over them. All right. Paste. There we go. All right, here's our question. Let's start with the numbers now, too. Missing some cats today, huh? All right. All right, determine, state the equation of a line. We talked on, let's see, what's today? Day 3. So Monday, we talked, if you want me to write the equation of a line, I need 2 things, slope, and what's the second thing I need to write the equation of any line? 4. Great, thank you. 18. Y-intercept. Yep. All right, let's deal with the slope first. All right, help me with the slope. 5x minus 4y equals 10. Get that into y equals form for me. Let's roll. Get that into y equals 14. First step. Subtract 5x. So I get negative 4y equals negative 5x plus 10. Next up, what do you got for me? 12. Next step to get y by itself. 4? Negative 4. Good catch. So I get y equals, what's going to happen here? Negative 5 over negative 4. Become positive, right? And then, honestly, do we really care what this is going to turn out to be? No. What we care about is right here, that's 5/4. But it says it's got to be perpendicular. So what do I have to do with the 5/4 to find my new slope? 3? Darn right. So what's it going to be? All right, there we go. So half of it's done. Negative 4 over 5. Let's go. Now, how do I find the y-intercept? We always use y equals mx plus b. Plug in a point we know is on the line and the new slope. So do that for me now. Oh, no. 11. Y value I know is on this line. 12. It's in the problem. Slope. -11. Keep rolling here with me. Slope. Negative 4 over 5. X coordinate it goes through. 5. And now we're solving for B. Add the 4 over when you're done. We should get 16 as our y-intercept. And now all you have to do to get full credit here, put the two together. Y equals negative 4/5 x plus 16. Good, Luke? Okay, quick question before we leave this. What if I change the word perpendicular up there to parallel? How does this problem change? If I said equation of a line parallel to this, how does this problem change now? I want to get you ready for everything. 6, how does this problem change?
The slope will be the same as your original.
So instead of flipping it, I'm going to take 5/4 and plug it in over here and get a new y-intercept. Yep. Anything else? Part 2's going. We got one last day in this packet. All good? Everyone changed their mode back into degrees, correct? Because that's what part of our topics are today, our sine, cosine, tangent. So go to your review packet, have your cold hard facts ready to go as well. You may need to reference that. And I would like to start on this problem right here in right triangle shown. All right, so let's start using sine, cosine, tangent again. All right, this is a basic problem. All right, very basic. I got 30 degrees. I got 24 for the hypotenuse, and I have x over there. Now, could you use your 30, 60, 90 rules? You could. This is a 30, 60, 90 triangle, but you don't have to. You can use sine, cosine, tangent here. So I'm going to need your help. Which one do I need to use here? Okay, 15. What's the x compared to the 30? Oh, hey. 3. What's the x compared to the 30? Adjacent. And how about the 24 stuff? Good job. So Stella gave us adjacent and hypotenuse. So which one of the 3 ratios could I use here, or only can use? 16? Cosine. All right, good. So cosine, I write the angle in, 30 degrees, is adjacent side x over hypotenuse 24. And this is why you need to turn it back in the degree mode. And some of you guys put it over 1 and cross them up for me. And we end up with 21, I believe. All good. Don't need to ask anybody how you type numbers into the calculator. So, okay, I'm finding a side. All right, next one's find an angle now. Ooh, that was something we got to remember how to do here. Find an angle. Find angle A. All right, so what's the 9 and the 14 first? 6, 9 and the 14 to angle A.
Adjacent, hypotenuse.
Yep, 9's adjacent, 14's hypotenuse. Which ratio do I use with this one? 19. Cosine. Here we go. Cosine. What do I plug in for the angle now? I plugged in 30 on the last problem here. X, A, because we're finding angle A, it's up to you. X equals adjacent side 9 over hypotenuse 14. We do not cross multiply here. When you find an angle, we do not cross multiply. Anybody remember the special calculator? Molly! Perfect. Inverse. Remember using the inverse? X equals the inverse of cosine 9 over 14. So that's your second button in cosine on your calculator. That's only for finding an angle. If you find a side, you cross multiply. And everyone getting 50 out? 50? Perfect. Any questions there? So just want a little reboot of sine, cosine, tangent, how to find a side and how to find an angle. Whew, all right, this one comes up all the time, and we got to just remember the rule. Cosine of 72 is equal to sine of what angle? Anybody remember? If I set cosine and sine ever equal to each other, if I ever set those equal to each other, anybody remember? And it's over here already, but what do you have to know about A and B? Romeo?
Supplementary.
Ooh, wrong word.
Complementary.
Which means what? Adds to 90. If I ever see cosine and sine equal to each other, their angles have to add to 90. So x will be equal to 90 minus 72. Okay. And then I got 18. All right. Don't be fooled by those questions. You got to say angles have to add to, don't set the angles equal to each other, make them add to 90. And executive decision right now, I'm getting rid of the next problem. I don't like it. All right. I don't like it. That's what I want you to know right there, that they add to 90. Save us some time. We good? All right. I don't think we're done though. D3. Hey, sectors. Let's see. In this diagram, the area of the shaded sector is 12 pi. What's angle AOC? All right, a formula that's not given to me, so I'm going to have to make sure I know it. I gave you that sheet of formulas that you'll need to know, right? This is one of them, area of a sector. So I don't know, you guys want to get that out and so we can write it in? The single sheet I gave you guys with all the formulas that are on the formula sheet. Just so we can at least get one filled in, right? You guys are on your own for the rest of them, or most of them anyway. So keep that sheet out. Everyone see where it says area of a sector. Okay, I give you, there's two formulas, one in degrees, one in radians. Let's talk about the degrees one right now. Measure of the arc over 360 times pi r squared. There's the area of a sector. You can fill that box in. Area of a sector. Measure of the arc over 360 times pi r squared. All right, let's use it. Remember, we're trying to find the angle. So where in the formula would I need an x? Think about that. And I need to solve for that angle right there. All right, let's do this. 9. What's the sector area of this sector? What's the area of this sector right here we're working with? 12 pi. We don't need to find it. So everyone all right? I'm going to plug that in for Ed. 12 pi equals 11. Do I know the measure of the arc? No. But I know it's the same as AOC, which I'm trying to find. Remember, these two are always equal. That's where my x is going to be. Over 360. 9 times pi. What's my radius? 6 squared. There's the setup. There's the setup. Now how do you figure out x? What do you got on both sides? Pi's. Just get rid of them now. All right, what's your next move now to get x by itself? Because we could do a couple things here. Your next move. Here you go. 11, your next move.
I would get the 36 out.
So you want to divide by 36?
Yeah.
That's fine. You can divide by 36. Anybody multiplying by 360, you can do that too. You're going to have to do one or the other. You're going to have to do both eventually. All right, so you guys go ahead, finish that off, and I'll ask somebody what you got for your angle measure. So you can divide both sides by 36 and then multiply by 360 or reverse the order. So how many degrees are you getting there for x when you're ready? 13 when you're ready?
120.
120 degrees. Any issues solving that? Got to know the formula to get it right. Next one, very similar. Very similar formula. That's why I'm going to do it next. Not area of a sector, but length of the arc measure. Length of the arc. So everyone see that? We can fill that in on your sheet right now. Length of an arc. Hey, it starts the same way. Measure of the arc over 360. Starts the same way as the sector formula. But instead of multiplying it by pi r squared, you multiply it by pi d. Anybody remember what pi d was? Circumference, yeah. So instead of multiplying by the area like we did in the sector, you multiply it by the circumference instead for arc length. So there's your arc length formula. In degrees, anyway, in degrees. I really don't think you're going to have to worry about the radian one, but we'll eventually review it. All right, so here's Big Dom. He thinks angle A and B have the same measure. Is he right or is he wrong, huh? Is he right or is he wrong? Let's find out. Arc length. They're giving you the arc length here. So let's go circle one first. Do they have the same angle measure? Eight. No. 3 for 3. I'm going to do it. 5. Ready, Jackson? What's the arc length on circle 1? What are they labeled? How long is that arc? What's on there? The length of this arc right here, circle 1. Pi. Yep. So everyone ready? Pi equals 18. Do I know the measure of the arc? Oh, that's what I'm trying to find. You can put an A, you can put an X in there. I don't care. Over 360 times pi. What are you putting in for diameter? 4. 17. What are we putting in for diameter? Not here. 3 for 3. 7. 8. Thank you. Ooh, watch out here. I'm a little nervous here. What do you still have on both sides? Okay, now a blank? 0? What's left on the left side here? You can't write. You got to write something in, right? And it's not 0. pi over pi, 2 over 2, 3 over 3, still leads to, yes, 1. 1 equals a over 360 times 8. And just like last problem, you do your magic now. $45? $45? How about circle 2? Help me out with circle 2 now. 18. Let's ready to roll. What's the arc length of circle 2?
13 pi over 8.
Equals b now over 3, or x again, I don't care. 360 times, diameter for pi d. 18 again, diameter.
13.
13 pi, or pi 13. What do you still got on both sides? Okay, they're gone, you know that. And I didn't get rid of it. One job. There you go. Divide by 13, multiply by 360, still going to get the same result. $45 still? So Dominic is correct. It says explain why. There's your explanation. Look at my work. Okay. Anything you want to ask? I'd like to see you do the next problem on your own. Because now again, we're talking about area of a sector, BOD. Look at area. What's the area of sector BOD? And they're telling you, everyone see the two arcs that are congruent, because that'll help you out too. Arc AC and arc BD are congruent. Find the area of the sector. You're up. Use your formula. See if you can fill it in. Okay, my first question. How do you find the measure of the arc? Like A angle, B angle BOD. How'd you find that measure right there? Okay, that's what we needed first here. How'd you find that measure? Little explanation here. 16.
I found it since A angle AOC and BOD are both congruent.
Correct. Yep. If their arcs are equal, so are the angles. Keep going. Yeah, good.
So and we know that COD is 20.
Yep.
You can subtract 180 from 20 and divide 160 by 2.
So you get what?
80.
Great job. Perfect explanation. There's 80 degrees right there. And how about the radius? Because that was not given. 10 radius. 2 radius. 6. There we go. And did everyone read the directions? In terms of pi. So you should have had the pi in your answer, not touched in your calculator. 80 over 360 times 6 squared, right in your calculator. Leave the pi there. And we end up with 8 pi. Okay, sector and arc length. I'm going to make an executive decision here. I don't think there's any need for us at this day, Wednesday, June 8th, to be doing volume when we just finished it. Okay, so if you come to a review session, I'll have you do a few problems, but I don't think it's necessary to do it right now because we just finished this. Anybody remember the ice cream cone here? Yeah, we did this problem. Okay, so I'm going to save ourselves some time here. I'd rather go over. Oh, did that problem, right? Did hemispheres, yep. Oh, the bricks in the trailer. Everyone remembers that one. Oh, the snow cone, yep. How many can cost of 50 of them? Partitions. Let's roll, huh? It's been a while, but you know you're going to see them on there. Here we go. I'm not going to use the graph until at the end. I never taught this to you using a graph, so I'm not going to use it until the end, and I'll show you. So I got point A and point B. Got to break it up into a ratio of 2 to 3. How many congruent parts is that going to be then? 5 congruent parts. So AB is going to be broken up into 5 congruent parts. I want to find the point that breaks it up on 2 on the left, 3 on the right. That's what we're looking for. What point breaks it up in 2 on the left, 3 on the right? All right, here's how I taught it to you. So here's how we're going to review it. First thing we do, we find the x coordinate. Let's find the x coordinate. First thing you have to do, what are the x coordinates of A and B? Somebody identify those. What are the x coordinates? 6, what are the x coordinates?
-6.
Okay, so what you guys have to figure out in this first step is, what is the distance on the x-axis from -6 to 4? What's that distance? If you counted all the units from -6 to 4, how many units would you be going total? 3? 10 units total. So this line segment on the x-axis is 10 units total. You guys just told me you need to divide it up into how many equal parts? Okay, so divide that distance by 5. And I'm going to end up with 2, which means start at A, go 2 units, you're broken it up. Go another 2 units, you broke it up. Go another 2 units, you broke it up. My question is, though, how many times do we need to go 2 units? How many times do I need to go 2 units? And your answer is the first number in the ratio. So how many times are we going to go 2 units? Twice, for a total of 4 units. 4 total units. So that's how many spots I'm going to go on the x-axis. Where did I start on the x-axis? Luke, going back to you, where did you start on the x-axis? At what coordinate? Okay, so I'm going to start at -6, where I start, and go 4 units over, and end up at -2. So there's my x-coordinate. Now, it's same exact process to find the y-coordinate. Same process. Now, look at the y-coordinates. Tell me what they are. Identify them. 7, identify the y-coordinates. Okay, everyone ready? -5 to 0. How many units is that on the y-axis? You start at -5, go up to 0. How many units? 12? 5 units. Still divide it by 5, because that's how many pieces you told me to break it up into. So now I'm going 1 unit every time. Do not get confused. How many times do I need to move 1 unit on the y-axis? It's still the first number. I am never using the second number in the ratio. I don't even want to tell you what it's all about. We've used the first number in the ratio. So I'm going to move 1 unit twice. 1 unit twice for a total of 2 units. Tell me what y coordinate you started on. Who gave me the y coordinates? Who just gave me the y coordinates a couple seconds ago? Emma, what y coordinate did we start at? Okay, everyone. So go from -5, start there, and go up to -3. So my partition point, what are they calling it in the problem? Point P. Maybe. You know you have your formula sheet in the back of your packet. In the back of your test, and a scrap sheet of graph paper. How many hours do you have to take this exam? 3. You can leave after 2. Let's be honest with each other. What is going to be so important in your lives from that 2 to 3 hour mark that you can't do some checking of your work, that you need to leave immediately after 2 hours? The answer, I'll answer it for you. Nothing. All right. See how I provided a graph here? Graph AB for me, please, right now. Graph that line segment AB. I'm going to show you how I want you to check your answers come game day. So graph AB for me. -6, -5, and 4, 0. You can just freehand it now, but on the day of exam, grab your straight edge and actually connect them. Your partition point better be on there. Better be on there. If it's not on the line segment, we did something wrong. Okay? So that's a quick check if you're doing the partition questions right. It should land on the line. 1, 2, 1, 2, 3. There's my partition point, landed right on the line. Just check it. Just check it. You're not going anywhere. Nothing's that important. And for most, I think all of you, it's your last exam too, so we could spend a couple extra minutes. Yeah, it's your last Regents or your last final Regents, whatever you're calling it. I don't think you have anything else on Wednesday and Thursday. Those are the last 2 days. And that's another math exam on Wednesday and physics on Thursday, which I don't think anybody's taken as freshmen and sophomores. So, okay, you good? Partitions? Did I give you another one to try? Oh, I did. Go right ahead there, kiddos.
Okay.
Directed line segment PT. 2 to 1. And then check it when you're done. Two five looking good? 2-5? And it ended up on your line when you checked. All right. I want to make sure we have enough time to do circle stuff tomorrow, because that's the last part of this packet is circles. And we're not going to have enough time in the next 7 minutes. But you know what you do have time for? Get out your January 2020 exams. If you feel comfortable working with other people here, go to the very part 4 question, the last questions. 6 points. It's been a while since we've done some of these, but approved. Part 4, question 35. Part 4. There's only one part 4 question on there. It's probably going to be approved. I think. I could be wrong. Just to get you guys kick-started, because it's been a while, notice the proof statement, FG and EG. Only way we're doing that is if what's congruent first? Triangles. So right before you begin, find a pair of triangles, because there's only one pair that contain FG and EG, and try to get them congruent to each other. This one's a tough one. That's why it's 6 points. All right, so I'm going to end class on that. If you get stuck, call me over. You got 5 methods to prove those triangles congruent.